Limits, we're pretty much done with derivatives. We'll continue to work on both of those the rest of the year. So we're about 2/3 done with our course. The other part of it is calculating the area under a curve. Okay, we're going to start by approximating that geometrically. And then we'll move into getting the exact numbers, which involve antiderivatives. Okay, so basically what we're doing is we're looking at...
This one you do like the rectangles?
Yeah. We've done this if you were in my class anyways. Okay.
Isn't there like one where you do like...
Basically, we're moving from your geometric shapes were all nice and pretty squares and circles and triangles, right? Mm-hmm. Well, now we're going to add a component of a curve to that. That's what the next step up, because guess what? In the real world, very few shapes are actually perfect, right? So we need some method to calculate areas of funny shapes, right? So start with approximating. If you are given a function of some kind in which to graph it, one method is called a left Riemann sum. Are we okay?
Tell us, stop talking.
Should I have like a kick me sign on my back or something?
Yawn
Yes. Okay. Left Riemann sums involve rectangles that start on the left boundary. So in this case, we start at the left, so this is where the function intersects at 0. You draw a rectangle from the left over. Does this ring a bell for some of you? Okay, and then the next one, and the next one, and the next one, and you're done. Okay. And then you would calculate the area of all those rectangles and add them up.
That doesn't seem very like...
Okay. We would call this, we would say this has 4 subintervals. Why? Because there are 4 rectangles. Okay.
So like the approximating part, where you're just using the rectangles, would that be like on the non-calculated part of the test?
Yeah, probably.
Are there always going to be as many subintervals as there is calculated numbers?
No. If I did 2 subintervals,
Is the more so subintervals more accurate?
what do you think?
Probably.
Yeah, so the more rectangles you have, does it look like it's going to get more accurate. Okay. And an integral is what we call an integral. One way to approach that is to make these rectangles as small as infinitely possible so that they exactly match the curve. Okay. Now you're not going to have to calculate the area of 1 million rectangles. Okay. We got some antiderivatives to help us along that route. Okay. What?
Why'd you change it to 2 something?
Just to show you that you can do different intervals. So how wide would this rectangle be? The blue one?
Twice as much.
2 times whatever height, you get your rectangle
How do
area.
you know the height?
That is weird. Is this an over or an underestimate? It's an underestimate of the exact area, right? We'll get to that more formally, but just the way it is. Okay. Right Riemann sum. It's very similar. Where does it start? It starts on the right. Okay, so a right Riemann sum would start here. German. It's not okay.
Oh,
Yeah, it is an overestimate. Okay, how many subintervals? 4. 1, 2, 3, 4 subintervals, right? Okay. So we would say, here's how you note this. Okay, and this is the general calculus notation for area under a curve. We would say, in this case, either of these, there's your symbol. Okay, that funny squiggly you see once in a while, we're now going to start using it. So this is basically the formal word. So we call that an integral. Okay, you can interpret it as area under a curve. So the integral from 0 to 4, the area under the curve from 0 to 4 of the function is approximately, okay, in this case we're still doing approximately, so we use the double tilde, and then you have some answer. No, it's F.
So let's say things are just
So this is just, this would say,
absolutely.
so you might, your question might say, approximate this with a right Riemann sum of 4 subintervals.
How do you know how many
Okay,
subintervals?
so you might say approximate that with a right Riemann sum of 4 subintervals. I'll show you a couple problems.
Is it going to show you how many subintervals?
They'll tell you?
Yeah.
Yeah. It's a use 4 or use 2. We can also note this as, that means a right Riemann sum of 4 subintervals. Okay. This would be left sum with 2 subintervals. So it might say calculate L sub 2 with 4 f of x from 0 to 4. Okay, there are a lot of ways we can ask the question. Okay. You have to read it.
Where does it find it?
When we get a function in here, we calculate the antiderivative and evaluate, it should be the exact answer.
Okay, so that,
So we'll get there,
yeah.
we'll get there. But this is just approximating for now. Okay. Let's see. Okay, I'm lost. Yikes. Let's calculate L4 for start. So you're given a basic algebraic equation. Oftentimes you will not be given a graph, but it can be given to you. So how many subintervals? 4. So how big are each subinterval?
2.
They're 2 units each. 2, 4, 6, 8, right? Do you want me to draw the graph?
Yes.
Okay. Oh, that was dumb. Dumb, dumb, dumb. Let's go in. Oh, I'm just sketching it. This is just for you to see what's going on. Okay, the first rectangle is how starts here at 0, right? How tall is that rectangle? There's nothing. 0 times 2. So it's 2 units wide, but there's no height because this graph starts at 0, 0, right? Okay, how about yeah, so the x value is 2, which means the height is 4 and the width is 2. So 4 times 2. Okay, what about the next one? 4 squared is 16 tall and 2 wide. Right? And then 6 squared, 36 by 2. You see what we're doing? We're putting a rectangle, calculating the area. So the integral from 0 to 8 of x squared is approximately, and then do your math. Once again, is that an acceptable free response answer?
Yes.
Wow. Duke it out.
I just said no.
Yes, because
Is
it's
it
all
completely
numbers.
numeric?
Yes.
You're good on a free response. Don't touch it. Always simplify on your practice work. Always. Okay, 0 plus 8 plus 32 plus 72, which is 112. That's L4, correct? Well, L4 does equal that right there.
Wait, what is this squiggly line for us again?
Approximately.
Approximately.
So this is telling you to get the this is exact, right? But we're not doing exact. So we have to say this is approximately, or we can say L4 is 112. Because L4 is equal to 112. But this is only an approximate. Okay, so we're being very picky. If necessary. All right. it is possible, are you caught up? So a graph is one way to tackle this. A table is another. I like tables the best because they make it really easy. Right?
Six is 36.
Yeah, it is, isn't it? Thank you.
Nice job.
Little into that. I was laughing at your comments that were not meant to be heard.
What is that number?
What number they weren't?
36.
36?
You corrected it by saying table.
Okay, how would I use that to do a left Riemann sum? How wide is this rectangle? 2. And how high? 0. So you get started on the left. So there's your height. And then your width. Okay. How wide is this rectangle? And how high? And then this one? 2 times 16 and 2 times 36. And there's your left Riemann sum.
So if you were going right, would you just do it?
Start at the right.
Why?
Yeah. You just start at the right. Yeah, it's start left or start right. It tells you exactly what to do. Yes, you would here, 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 and here. And this will be like for a right Riemann sum. Okay. Questions? Okay. Okay, so left and right Riemann sums. We're almost done. Okay, this is one of the pages that you'll be working off of for your practice. I will only be asking you today to do the left and right Riemann sums, but you can see the notation, right? 0 to 120. Here's a table, just like I just showed you, the left and right Riemann sums. Okay. Here's another table, some practice. But here's a graph. So I showed you how to do it on the graph, right? To draw the rectangles up. Okay. And I showed you how to do an equation as well. You can build a table or you can build a graph. Okay. If I was given an equation, I would build a table. Makes it easy. Okay. Caleb.
How do you do the right sum of the table? You just draw the line.
You start on the right. Your height is 4.8.
Okay.
Your width is 20.
Oh, okay.
Right. How many intervals? 6. So 1, 2, 3, 4, 5, 6. So they've already set you up there. So 4.8 times 20.
Yeah.
5.2 times 20. 5.1 times 20. 4.7 times 20. Get it?
Okay.
If that's from the right side. Okay? And then again, on the graph, from the right side, start on the right. Draw your rectangle. Draw your rectangle. Draw your rectangle. Okay? Homework space in the classroom. It's due tomorrow. Tomorrow we'll talk about trapezoids and midpoints. So practice with Riemann
Someone
trapezoids.
stole my idea of the
Tomorrow we're talking about traveling.